let's try to understand now multi-dimensional arrays. To understand multi-dimensional arrays, so I start with two-dimensional array. So generally, whenever in my real world I have a matrix, example 3 by 3 matrix. Okay, so there are three rows and three columns, 1, 2, 3, and they are all, let's say, students marks. There are three students and there are three subjects, I can say subject 1, subject 2, subject 3, and there are three students, so their marks maybe 20, 30, 40, so 50, 60, 70, and 20, 80, 90 something. So this is the data. Whenever this kind of data if I want to represent, then I go for two-dimensional array. So how to declare it in C programming is int three rows and three columns. That's why let's give, these are all marks, right? Let's give meaningful name int marks of 3 by 3, 3, 3. So whenever I do that, how to access it, we'll see. Example, I want to initialize it like this one. Then you write equal to 20, 30, 40, 50, 60, 70, right? Then 20, 80, 90. This is the initialization. Okay. So if you have already data, then you can initialize, otherwise later you can fill. But how to fill it, like how to access? From now onwards you have this kind of storage whenever you do this. Okay, then how to access that storage? Example, you want to access this position. Okay, so forget about the data, you want to access this position, then how to access? From now onwards you write marks of 0, 0. Similarly, to access this one, it is 0 through first column. In C programming, index starts at 0. We know that, right? That's why it will be marks of 0 through. So in my high level, it is first row, second row, third row. But in programming, it is 0 through first row, second row, 0th column, first column, second column. That's why it will be marks of 0, 0. And you can change it. Like whenever you write marks of 0, 0 to 50, then this will be affected and it will become 50. Okay, so in that way, this is my high level imagination, but I don't know really how my data is stored. But whenever if I want to access this 0 through 0th element in my high level imagination, then you can access marks of 0, 0. Only that thing I know. Okay, then marks of 0, 1, whenever you access, it is like accessing 0 through first column. That means this element. Okay, so in that way you can access up to marks of second row, second column. Syntax for accessing it is marks of 2, 2. Okay, so this is the basic idea about two-dimensional array. Now how to understand, I'll give you some low level details about this two-dimensional array. So whenever you have two-dimensional array, you imagine that two-dimensional array like this. Okay, so example, marks of 3, 3. How to interpret it is, you have this is again our imagination. So if you imagine your data like this, it will be easy to write the program. And that, since it is two-dimensional array, we can see two dimensions, right? This is dimension number 1, this is dimension number 2. Okay, so marks of 3, 3, that means you have three arrays, and each array has, it is like you have three arrays, each array has three elements. See, you have three arrays, each array has three elements. So that's why, let me show that three arrays here. Okay, now this is the idea. Whenever you declare marks of 3, 3, you can interpret that structure like this. Okay, again it's a high level imagination. In the low level, what happens we'll see later. Okay, I will be telling that later. Now this is 20, this is 30, this is 40. So what is this one? This is one-dimensional array. So this entire thing is two-dimensional array. Then all these things are one-dimensional arrays. In one-dimensional array, actual integers you can see, correct? 20, 30, 40. Now next, in the second array, 50, 60, 70, and here you can see 20, 80, 90. Okay, so this is what happens. Now this entire array's name is marks. Okay, you can interpret marks like this. Marks is a pointer to this kind of objects. Now question number 1, what is marks? So how to interpret marks? You can interpret marks as a pointer to, so this kind of, for it objects are these things. So this is an object. Before that, to understand it clearly, let's go to one-dimensional array. I'll come back to marks and two-dimensional array back. Before that, let's understand one-dimensional array clearly. With respect to this idea, example, if you have int a of 5, then that is nothing but you have an array with 5 locations. 1, let's say this is 0, 1, 2, 3, 4, isn't it? So now this is, so integers are objects here. See, int a of 5. Example, the values are 1, 2, 3, 4, 5 for time being. So what is a here is, I will tell you. Here a is nothing but it is a pointer to, see, a is a pointer to, already I told you, integers, correct? Whenever you have one dimensional array, a can be imagined as a pointer to integer. Okay, whenever a is a pointer to integer, then it points to what? Integer kind of object. That's why a is pointing to first object. Now that's why whenever you print a array name, it gives what? Starting address. Example, starting address is 100. Let's imagine this is, let's say, 104, 108, 112, 116 in physical memory. Then printf a, if you print address of a, otherwise a, what will be printed? 100 will be printed. That's the reason. Okay, now what I want to tell you is, when you increment a, what happens? Example, if you do a plus 1, that means I am not updating a. Please remember, one more time I am telling, a cannot be modified. The reason, a is specially, a pointer which is called base pointer. You can't modify that base pointer because specially it is given for you to use this array, but there is no meaning of modifying it. Correct? Try to understand the purpose of a. Purpose of a is only to show you that this is the starting address of the array, but if you modify it, there is no meaning for it. That's why array pointer, whenever you have an array pointer, that means a, that means I can say a is the owner. When you have owner a, don't modify him. Okay, now but you can add plus 1 to a, right? Because you want to access all these elements. Example, a plus 1, what happens? It will be 100 plus 1, which is 104 in pointer arithmetic. Why it is 104? 100 plus integer size. The reason a is a integer pointer. Okay, that is a imagination. Now that's why it will move like this. From now onwards, you remember, whenever a is really, if you want to increment a, then if a is here, it will be a plus 1 will be here, a plus 2, a plus 3, a plus 4. So however a cannot be modified, what we do is, let's say I have integer pointer a, like integer pointer p, one more pointer, which is, new pointer. If I write p equal to a, what happens? P also points like a points, then this p points like this. Okay, now it is integer pointer. Whenever integer pointer is incremented, what happens is it will go to the next integer. That's why, that is what you should understand. P plus 1, p plus 2 in that way. If you do p equal to p plus 3, so how to understand this statement is, p should be updated with p plus 3. See, I will try to understand what is p plus 3 now. This p can be modified. Now you should not ask this question. Why p can be modified? Because p is our pointer. So this pointer can be modified to anything. But a is a array pointer, that means it is a pointer which is, a is the nothing but owner of this array, that owner cannot be modified. Okay, so but p is not an owner of this array. So today it is pointing here, tomorrow it may point where, somewhere else. That's why don't worry about it. So p can be modified. When p is modified, what happens, we'll see. You have to move p to plus 3. Then see, this is p plus 1, p plus 2, p plus 3. Since p is an integer pointer, that's why I'm moving 3 integer objects. Okay, that is very important. Now when you do p equal to p plus 3, p comes here to this pointer. That means p points to 112. Okay, now come back. So when we come to two-dimensional array, then marks is a name of this overall array. How to interpret marks is, now he is a pointer to this kind of objects here. He is a pointer to this kind of objects which are shown in circle. What is each circle? That circle is an array of 3 objects. Okay, so marks can be imagined as, now I am writing it, marks is a, you can imagine it as a pointer to array of 3 objects, that you should understand. But don't get confused with this one. Then what is a here? A is a integer pointer. Okay, a is integer pointer. That's the difference, because objects for a are integers. Okay, that's the reason when you add plus 1 or plus 2 to a, or plus 1 or plus 2 to p, we are moving with respect to integer units. That means 1 integer unit, 1 integer, 2 integer units, so on. In the same way, Now, why these things are very important for us? Like, I mean, so why they are really good? I will tell you. Now, if you understand that your marks, whenever you declare two-dimensional array marks of 3 by 3, then that marks, if you add plus 1, what happens? I will tell you. Try to add plus 1 to marks. So, what happens? We'll see. We can't update marks because marks is again a base pointer. Marks is specially given for this array, right? It is representing this array. Then don't change, address of marks, otherwise content of marks. Okay, that is not meaningful. Okay, so that kind of operation you never try to apply for, I mean, owners of the arrays. Okay, that's why. Now, this is marks, right? When you do plus 1, marks plus 1, what happens? We'll see. Since marks is pointing to array of dash 3 objects, right? Then when you increment marks, then what happens? It will go to another such object. What is the next such object? When marks, I mean, first object it is, this one is first object, then second object is this one, right? That's why marks come to this point. Okay, now see. Now that is important. Again, if you do marks plus 2, then what happens? This marks comes to, like, just it will show this one. We are not updating. We are adding just plus 2 and we are seeing the resultant value. Okay. Then it is like we are seeing this one. Understand? So why it is useful, I will tell you. Now we'll see some more things which generally we encounter in programming. One is this one. So if this is marks, this entire thing is marks, then what is this one-dimensional array? So this one-dimensional array can be accessed using a syntax called marks of 0. Okay. So this is marks of 0. We know that, of course. This is marks of 1. This is marks of 2. Again, marks of 0, marks of 1, marks of 2 are referring arrays, right? It is like a one-dimensional array. Marks of 0 behaves like a one-dimensional array pointer. Recall how one-dimensional array looks like this, right? There will be an array, and example, if you declare int a of 5, then what happens? A will be pointed to first integer, of course. Then can we modify a? No, we cannot modify. In the similarly, so now marks of 0 is exactly like a. Okay, the only difference is this, I can say that this one-dimensional array is contained in two-dimensional array. Apart from that, all the properties, I mean, whatever the property a has, all the properties this marks of 0 will have. Okay, now similarly marks of 1, marks of 2 are all pointers to 1, I mean, they are all one-dimensional arrays. Okay, so where marks of 0 points, where a points? A points to the first integer of the array, right? Similarly marks of 0 can be imagined as, it points to the first object, which is nothing but integer, correct? Now, because in one-dimensional array objects are integers. In two-dimensional array, for two-dimensional array pointer, objects are one-dimensional arrays. Okay. Now, example, when you write marks of 0 comma 0, so why 20 will be printed, I will tell you now. First of all, marks of 0. So marks of 0 is what? This one. It refers this pointer. Will come here. Let's say we say x. Okay, marks of 0 is x. This pointer x. Okay. Now, so x is what? What is behavior of x? X is now pointing to integers, right? That's why. Now it is like x of 0. Correct? I am assuming marks of 0 as x. Then x is a one-dimensional array pointer. Then using one-dimensional array, if you do x of 0, what happens? You know that. Example, you have a one-dimensional array. If you do a of 0, what happens? This will be accessed, right? In the same way, when you do this x of 0, x is a pointer to the this array. That means it is pointed to one-dimensional array. Then it points to all the first integer. When you do x of 0, what happens? Star x plus 0. That means it will be star x plus 0. Otherwise, directly we know that it is 20. So why it is 20? Rather than doing this calculation, directly I can say, since x is a pointer to integer, when you refer it, see, star x plus 0 is nothing but star x. Whenever x is a pointer to integer, when you dereference it, what happens? That integer will be displayed. That's why 20 will be displayed. To understand it clearly, let's take marks of 2 comma 1. What happens? We'll see. Marks of 2 comma 1. Let's focus on marks of 2. What is marks of 2? So marks of 2 is nothing but this pointer, right? So this pointer is pointing to the first integer in this third array, right? Since marks of 2 is the, it represents this array, like this one, where A is representing this one, right? In the same way, marks of 2 represent this one. Then, if you do marks of 2 of 1, let's say this is y, then y of 1, it is like y of 1. Whenever you do y of 1, where y is the owner of this array, then y of 1 will become like this. This is y of 0, this will be y of 1, right? That's why 80 will be printed. So in that way, you can easily understand this syntax, what is marks of 0, 0, how marks of 2, comma 1 works. Okay. So now, can we modify marks of 0? Sometimes in exams they give like this, marks of 0 plus plus. Can we do it? No. That means you are modifying marks of 0. You can't modify marks of 0. The reason is you can't modify A, right? A equal to A plus 1. Can we do it? No. The reason, A is nothing but what A represents. A represents, it is a base pointer of this array, correct? So that base pointer cannot be modified. We know that in the same way. So marks of 0 also a base pointer for this array that cannot be modified. You can't modify marks of 0, marks of 1, marks of 2, anything. Similarly, you can't modify marks. But we can modify this one. What is that? Marks of 0, 2 can be modified. Plus plus. If I do, I am modifying marks of 0, 2. So why it is allowed? Simple. Marks of 0 to, if you do, so marks of 0 will come here, that means the pointer comes here on that 2, right? On that 0, 1, 2, this one, right? So it's a value, right? So marks of 0, 2 will be resolved to value which is 40, then 40 can be incremented, right? So this position can be incremented. That's why we are using two-dimensional array. If you are not able to use, increment it, then what is the purpose of taking it, correct? That's a uses, proper uses. Okay, only this thing you can do, other than that nothing we can do. Okay, similarly we'll try to understand three-dimensional arrays. Let's see three-dimensional array and same details. Okay, in three-dimensional array, so example, the declaration is int a of 232 equal to 1 to 12. Then we can imagine that three-dimensional array like this. Okay, so first of all, this is two-dimensional array, this is two-dimensional array, this entire thing is three-dimensional array, this is one-dimensional array. Okay, one-dimensional array, 1 1 1 1 1. There are 3 plus 3 6 one-dimensional arrays, two two-dimensional arrays, one three-dimensional array, which is our original one. Okay, now what are the pointers we use to access the three-dimensional array? We'll see. First of all, A. So how to understand A is a pointer to some object. What is that object is? A is a pointer to two-dimensional objects. Okay. For A, objects are, let me mark like this. This is star. This star box. Okay. So A is pointing to this kind of boxes. Star. Similarly, one more box is this one. So if you print, that's why A, what happens is, starting address of the array of course will be printed. The reason I can understand it like this. Since A is pointing to this kind of objects, and especially now it is pointing to first such object. So on that, what is the first memory address? Let me write the memory addresses. Okay, this object 1, integer 1 is at 100. Let's say every integer occupies 4 bytes. It will be 100, 104, 108, 112, 116, 120, 124, 128 and 132, 136, 140, 144. Okay. Now currently A is pointing here, so that means starting address in this entire memory is 100. That's why 100 will be printed. So try to understand printf A plus 1. If you print A plus 1, we are not modifying A. So don't remember one thing, we can't modify A because A is a base pointer of this array that cannot be modified. If I access A plus 1, what will be accessed? Okay, you should know them. So simple, it's a pointer arithmetic. Whenever you add 1 to a pointer, then one object will be moved. Since A's objects are this kind of things, if I move A, then it will go to the next such object. That means, it comes to this object like this. So A plus 1 is this one. Understand? So that's why, what is A plus 1? This object, and that starting address is 124. That's why 124 will be printed. Okay. Now if you do printf A plus 1 minus A, So why 1 will be printed, we'll see. Okay, a plus 1 minus a obviously should give 1, but I will justify it. Since a plus 1, if your computer calculates it, it will be 124 minus, what is a? 100. 124 minus 100 supposed to be 24, right? But still why it gives 1? The reason, it's point arithmetic and it has a purpose, I will tell you. Let's go to one dimensional arrays to understand it. Example, you have one dimensional array. Okay, example, there are 5 objects, 1 2 3 4 5, and a is the pointer to that, and starting address, let's say 500. My question is, a is 500. What is a plus 1? A plus 1 is nothing but 504, isn't it? So a is pointing to first integer, then when you move plus a to plus 1, it should go to the next integer, that's why that will become 504. So in this one, a plus 1 minus a is what we'll see. A plus 1 is 504 minus a is 500, then 504 minus 500 is 4, but when you print it, 1 will be printed. The reason is it's not about memory addresses. Generally people not concerned about memory addresses, they are concerned about their logic and their objects. That means people want to play with objects rather than memory addresses. In this, in particular example, whatever the machine I am using now, in that machine integer size might be 4, then you get output 4. Example, if only I use just ordinary arithmetic, not pointer arithmetic, then 504 minus 500 is 4 because integer size 4. If integer size is 2 bytes, then this address will become 502. Then 502 minus 500 is what? 2, right? Then in such machines 2 will be printed. To avoid this one, if this kind of things are allowed in the programming language, such programs cannot be executed under all the machines, correct? So they cannot be portable. To have a portability, then the designers decided that it's not about 4, it's not about 2. We should not give such kind of values. We should give number of objects, the difference between a plus 1 and a with respect to number of objects. Okay, it is like a is pointing here and a plus 1 is showing here. What is the difference between these two with respect to integer objects? Because their objects are integers, right? So that's why with respect to integers there is only 1 unit of difference. That's why I divide that by integer size so that I can understand the number of difference with respect to number of objects. In the same way, now come to this problem. In this problem, a of 1, I mean a plus 1 is 124 minus 100 is a, then 24. So divide it by, that's why better you divide it by the corresponding object size which they are pointing. So a plus 1 and a are pointing, what is type of object a? That's why it is important now. A is a object pointer which is pointing to two-dimensional object. So we'll calculate the size of the two-dimensional object. 1, 2, 3, 4, 5, 6. There are 6 integers in that object. Then 6 into integer size 4 bytes. It will be 24 bytes. That's why 24 will be divided by 24 again and you get 1. That's why it is justified. When you write a plus 1 minus a, so in pointer arithmetic also only 1 will be printed. Okay. Let's see some more pointers involved in this 3-dimensional array. First we begin with a. Okay. So when you declare this 3-dimensional array, you get a. So a is a pointer to two-dimensional array. Okay, two-dimensional object. What is two-dimensional object here is this one, here to here. Okay, there is one more two-dimensional object. So a is a pointer which is capable of pointing to this kind of two-dimensional objects. Okay, but currently a is pointing to the first such two-dimensional object. Okay, so what is that object name is a of 0. Okay, there is one more such object, right? That is a of 1. Understand? Now, what is a of 0? Similarly, like a of 0 is a pointer to, you see the arrow. It is pointed to one-dimensional objects. How many one-dimensional objects we have now in this object? Because a of 0 represents this object now. In that, how many one-dimensional objects we have? 1, 2, 3. So, first one is a of 0, 0. Second one is 1. Third one is 2. That's why this entire thing will become a of 0, 0. Since it's a pointer, it's like a pointer. So why it is a of 0, 0, I will tell you. Example, already we know that this is a of 0, right? Let's say x. With respect to x, okay, since it is a pointer to this kind of objects, now currently it is pointer to first object, okay, then how to access it? X of 0. What is this one? X of 1. What is this one? X of 2. Okay, then x is nothing but a of 0. That's why this box is nothing but a of 0 0. This box can be represented as a of 0 1. This box can be represented as a of 0 2. Okay, similarly this box can be represented as a 1 0, next 1 1 1 2. What are they? What is a of 0 0? I will tell you. A of 0 0 is a pointer to integer. That's the difference. Now let's summarize. This is A, okay, but A is a pointer to two-dimensional objects like this and like this. Next, A of 0. A of 0 is this one first now. Now it is A of 0 is this one. But what is A of 0 actually? What it does? It is a pointer to this kind of objects. What are they? One-dimensional arrays. Okay, then how to access that one-dimensional arrays? If really A of 0 want to access this one-dimensional arrays, then A of 0 uses syntax A of 0 0, A of 0 of 1, A of 0 of 2, right? Next, now what is A of 0 0 then? A of 0 0 is a pointer to integer. Then how to access that integers? A of 0 0 is a pointer to these integers. Okay, now this one and this one. Currently it is pointing to the first object. But how to access it? A of 0 0 of 0, A of 0 0 of 1. This is the final thing. That's why whenever you do A of 0 0 0 0 0 1, you get directly integers. What are the integers you get? 1 comma 2. Understand? Now question number 1 is, what is the output if I print A of 0 0? What will be printed? A of 0 0. Since A of 0 0 is a pointer, then it is pointing where? See, A of 0 0 is pointing to this object, and what is the address? 100. That's why 100 will be printed. Fine. What will be printed if I write A of 1? If I print A of 1 using printf function, of course, okay, then what will be printed is, see, A of 1 is pointed to one dimensional array, and what is the starting address of that one dimensional array? 124. That's why 124 will be printed. Now I am curious to know what is if I print A of 1 minus A of 0. We'll see. A of 1 minus A of 0. So what is A of 1? A of 1 is 124, and what is A of 0? See, go to A of 0. This is A of 0. A of 0's starting address is 100. Then 124 minus 100 is 24. 24 will be printed, but be careful. It's not directly 24. We have to divide by dash. Object size they are pointing. For that you should know what is the object size it is pointing. That's why I explained you all this story. A of 1 is pointing to what kind of objects you see? A of 1 is a pointer to one dimensional array, correct? So when A of 1 is pointed to one dimensional array, then its objects are what? Right? This kind of things, right? Then each such object has two integers. That means the size of A of 1, I mean object which A of 1 is pointing is this kind of thing. It has two objects, that's why integers are 4 bytes. 4 plus 4 8, 24 by 8 is 3. So that's why you get 3. What if you do A of 1 1 minus A of 0 2? What you get, we'll see. We'll ask first A of 1 1. Mr. A of 1 1, who are you? A of 1 1 is a pointer to integer, correct? You see, A of 0 0 is a pointer to integer. Similarly, A of 1 1 is a pointer to integer. And what it is pointing now? To 9. That's why what is the address? 132. Minus what is A of 0 2? A of 0 2 is also a pointer which is pointing to first integer in this array, that is 116. Then 132 minus 116 is 16, but we have to divide by object size they are pointing. What is the object size A of 1 1 is pointing? The object size A of 1 1 is pointing is integer, right? That's why I put like this. That's why integer size is 4. That's why you get 4. Okay. Now we'll go to logical level rather than this physical address level. So why A of 1 1 minus A of 0 2 is 4? I mean 4, I will tell you. Where is A of 1 1? Here, right? Where is A of 0 2? Here. Now what are the objects? Let's say A of 0 2 is here, correct? Here inside. Okay. Now A of 1 1 is here. Then with respect to integers, because they are pointing to integers, with respect to integers, how many integers? 9 is ahead of 5. See, 1 2 3 4. With respect to integers, there are 4 integers ahead, like a of 1 1 is 4 integers ahead of a02, that's why 4. So why this is 3? A of 1 minus a of 0. What is a of 1? A of 1 is pointing to one dimensional arrays. That means its objects are this kind of, a box with 2 integers. Okay, a box with 2 integers. A of 0 also a box with 2 integers. Now a of 0 is here, a of 1 is here. With respect to this kind of boxes, what is the difference between them? See, 1, 2, 3. That's why it will be 3. Understand? So this is the way you have to understand what is a, what is a of 0, what is a of 1, what is a of 0 0, what is a of 0 0 0, final one. Okay. So what is a of 0 0 0? Simple. What is a of 0 0 first? It is a pointer to integer, and especially it is pointing to now this integer. That means, so this is a of 0 0, right? It can point to this one and this one. So how to point to this one, how to access this integer? Simple. Recall everyone, if you have an array which can point objects like 1 2 3, then how to access the first element? So what is x? X is a pointer to integers, right? That's why it is pointing to now integer 1. But how to access 1? We write x of 0. How to access second element in that array? X of 1, isn't it? Similarly, a of 0 0 is such kind of one dimensional array. Then a of 0 0, using that, if you point to the first element in that array, then you have to write a of 0 0 of 0. So that's why whenever you write a of 0 0 0, 1 will be printed. Okay, they are real integers. Other than that a of 0 0 0, these 3 level things, all the 2 level things, 1 level things, everything are pointers, and they are called base pointers. You cannot modify them. Only this can be modified. Apart from that, remaining things only you can see them. Okay, so this is about 3-dimensional arrays.